Okay, I've already made a chart for graphing cosecant. Cosecant means that we're doing 1 over sine of theta. Remember, I was talking about they have different letters. So cosecant goes with the reciprocal of sine. And I've made a chart that already has the point 0, 0, pi over 6, 1/2. They come from here. 0 is the radian measure, 0 is sine. Pi over 6 is the input, we get out 1/2. We put in pi over 4, we get square root of 2 over 2, that's here. At pi over 3, it's the y value. It is the square root of 3 over 2. So this is the y value, and this is 1 over the y value. So I've already filled that in so that you can watch and follow. You can pause the video and make your own chart if you like. But what happens is we have the same deal where anytime y equals 0, there is a vertical asymptote. So where does y equal 0? Well, y equals 0 at 0 and at pi. So at x equals 0, we have undefined, so we have a vertical asymptote. And here we would have 1 over 0. So that is not something that's mathematically correct. So x equals pi, or x equals 3.14, is a vertical asymptote. Same rules as our word wall. And for the rest of them, we're just flipping the fraction over. Now some of these are decimals, so maybe we want to plug in our calculator so that we can get the value. I think we can probably do 1/2, okay? If we flip over 1/2, we get 2. This 1/2 will also be 2. So this is a point pi over 6, 2. This is 5 pi over 6, 5 pi over 6, 2. They're points. The square root of 2 over 2, most of us don't know by heart. Square root of 2, clear. I don't want to do that. I want to flip it over. So I want to say 2 over the square root of 2. 2 divided by the square root of 2. That's 1.14. 1.14. That means this will be 1.14. And then 2 over the square root of 3. 2 divided by square root of 3. 1.2. 1.2. And now right here, flip over 1, and you still get 1. So at this point, sine of theta equals 1 over sine of theta. These two functions are equal. Now let's take a look at what this looks like. I actually graph it every time by graphing sine first, because being the reciprocal function, it actually has some characteristics that sine defines. So sine defines the graph of cosecant. So it looks like this. I started with 0, so I'm going to put my origin to the left a little bit. Now I have asymptotes at every pi, from 0 to pi. So the asymptotes here are going to be at x equals k pi. And that will define the period as well, every pi. Period, I lie. Period is the same as sine. It's 2 pi. I had to do that in my head. And we'll see that in a minute why that is. So I'm going to do this as pi. This is pi over 2. 3 pi over 2. 2 pi. That makes this 5 pi over 2. 3 pi. 7 pi over 2. 4 pi. So I'm going to do 2 periods of this. Now at 0, I've got an asymptote. Here it is. It's a vertical line. X equals 0. It has to be a whole vertical line. X equals. And at pi, I have 1. and then it will go around again. I'll have one at 2 pi, and I'll have one at 3 pi. I'll have one at 4 pi. Now I told you that I needed to see what it looks like to have, so I'm going to do y equals sine of theta, or f of theta, do f. F of theta equals sine of theta, and it looks like this. Here's 1, and here's -1. And the sine graph starts at 0, 0. Hopefully you've got that in your head by now. It ends at 0, 0. It has to start and end at the same place to be the period. And sine is at 1 here, and it's at -1 here. So here's the graph of it. It does it again, so it goes up, and then it goes down. So that's 2 periods of the sine graph. Well, cosecant is the opposite of that. Here it is. At 0, 0, it's a vertical asymptote. At pi over 6, which is about here, it's at 2. At pi over 4, it's at 1.4. That's about halfway between. Pi over 3 is at 1.2. And at pi over 2, they meet. Then it starts to go back up. And it looks like tangent, actually. It will follow. It doesn't run smack into an asymptote. It is a fence. So it follows the asymptote very, very closely and then comes around and then follows it back up. So on the unit circle, which I'm going to pull back up, on the unit circle, all of these values are positive sign. And we get to pi, they're the same values, the same decimals, but they're all negative because sine is negative after that. So the next part of this goes down. It has the same shape, but it goes down. This one goes up. And this one goes down. So the graph of, this was g of theta, is cosecant of theta. This graph is only the red version. The blue here I have is just a guide, because if I can graph sine, I can graph cosecant really quickly. They're opposite of each other. They're the reciprocal function. So cosecant is the reciprocal of sine. When we graph secant, it'll be the reciprocal of cosine, and I can just graph cosine really quickly and sketch secant from it. So let's do that without the XY chart. So this is where you push the I believe button, and we're going to graph, we'll say h of x equals cosine of theta, theta, and then j of theta equals secant of theta, which is the same as 1 over cosine of theta. So cosine looks like this. Cosine goes through +1 and -1. It actually has the same period. I need to put that up here. Period equals 2 pi, because it has an up and a down between 0 and 2 pi. So if I try to make this match up, which I did a bad job of doing that, but we'll leave it. Here's pi, here's 2 pi, here's 3 pi, here's 4 pi. Cosine in one period starts at 1 and ends at 1. It has to start and end at the same place. In the middle, it goes to -1, and it's kind of round. It's round, and then it goes down, and then it's round back up, and then it's round and goes down, and then round and back up. So I'm trying to make it dotted so you can see it's just a sketch. It's just the guide. And then its reciprocal function is going to have j of theta has x equals, where is cosine, or x? This is 1 over x. Where is x equal to 0? Well, that's here at 3 pi over 2 and pi over 2. So that's right in the middle. So here are the asymptotes, right here in the middle, where x equals 0. You can see that same thing happened here, where y equals 0 is an asymptote. So that's 0, where this is 0, where this is 0, those are all asymptotes. X equals pi over 2. X equals 3 pi over 2. And the function that I need, secant, hits this same point and goes up, hits this point and goes down. It hits, pretend this was in the middle and graph pretty, because it's not pretty, it's not to scale. And then this one goes down. So every up they meet, that's the 1 over 1. And so the red, this is it is j of theta equals secant of theta. And there you go. There's your graphs. You're going to have to memorize what they look like. I've tried to give you clues. If you can graph sine and cosine, you can graph their reciprocal functions. Tangent and cotangent also have, that was the other video, but they also have asymptotes. But the period for these are different. So 4 of them have period. Sine of theta, cosine of theta, cosecant of theta, and secant of theta have period of 2 pi. They have an up loop and a down loop, because that's what happens around the unit circle. But tangent of theta and cotangent of theta have a period of 1 pi. And that's really important for our translations. All right, so there you go. Try to start memorizing these graphs so you can pick them out. There won't be a lot of translations with these that you would have to graph. You might just have to be able to spot it in your stuff. Okay, and there'll be homework posted for this. You should go ahead and work on it today, and we will review that in our next class period. All right, thank you.